guys, hope you're doing well. Hope everybody's settled and having a good time. And we're coming from West Virginia, as you can tell. So let me give you a little joke of the day. I'll teach you algebra, trigonometry, and even calculus. But graphing, well, that's where I draw the line. Alright, so let's get into it. We're going to take a look at quadratic equations. And with a quadratic equation, we are going to take a look at what a quadratic equation is, and then we're going to take a look at how to solve a quadratic equation. So first, let's take a look at the definition of a quadratic equation. It's an equation that can be written in the general form y equals ax squared plus bx plus c. The important thing to understand here is that when you take a look at this equation, the only things that are going to be variables are going to be the y and the x. The a, the b, and the c are going to be numbers. And in fact, they're going to be real numbers, as you can see stated right here. This is important because you just took a look at you just took a look at complex numbers. And we now understand that complex numbers are imaginary numbers. So basically this means that the a, the b, and the c, all these two coefficients and this constant right here, they are not going to be imaginary numbers. They're going to be real numbers. Fractions and decimals are okay. Irrational numbers are okay, positives and negatives are okay, but the idea is that we're not going to have any imaginary numbers in there. The other thing to note is that this a right here is not going to be 0, because if this a was 0, you guys know that that means that this entire term would be gone, and if it's gone, we no longer have a quadratic, we have a linear equation, which is what we've looked at before, where the power on the variable is going to be a 1. So you can see that the power on this variable right here is going to be a 1, the power on this variable is a 2. That's what makes it a quadratic, is having a second power in your variable. Now once you know that you have a quadratic, you can graph that quadratic, and you can see that the graph of the quadratic takes this special look to it. When it was a single power, or a first power exponent on the variable, that made straight lines. But now that we have a second power, when you graph it, it's no longer straight lines, and it's going to be a curve. Now, the curve is called a parabola, or as I like to say, parabolas. But anyways, the parabola takes this curved shape. The curve can flip up, or it can flip down. It can flip to the left, or it can flip to the right. Now, for our purposes, we're going to stick with either flipping up or flipping down. And so that means that our second power is going to be on the x. If the second power was on the y, and the x was to the first power, then that would make our parabola flip to the left or to the right. But we are going to deal with all the x's being squared, so that means our parabola is going to flip up or flip down. When we take a look at the next section, that's where we're going to describe to you how to determine whether it flips up or down. But for right now, all we're going to deal with is just being able to solve this quadratic equation. Now, when we solve it, you need to understand that there are special parts of this curve that we're looking for. And those special parts are sitting right here and right here. And you know, because of what we talked about before, that being that these 2 points are where the graph crosses this x-axis, recall that whenever a graph crosses that x-axis, we call it an x-intercept. Now, sometimes that x-intercept is called a root, so I'll just write that in here. And oftentimes I do call them roots, especially when I'm dealing with a curve. But they are also called x-intercepts. Now, remember that anything that crosses this x-axis, every point on that x-axis has no up or down movement at all, and it is the y value that designates up or down movement. So what will happen here is, in this quadratic equation, we'll get rid of that y, and it will become a 0. And then when it becomes a 0, we're going to solve for that x. So being that that's the case, the root is going to be the solution to your quadratic equation. It's going to be the value of x when that y is equal to 0. So because of that, sometimes your roots are called x-intercepts, sometimes they're called roots, sometimes they're also called zeros. But do know that all three of those mean the very same thing, and honestly, sometimes they're called solutions. So we've got 4 different names for the very same thing, which you know drives me nuts. I think one name is perfectly fine, but they all do mean the same thing, because if you think about it, it is an x-intercept because it's where it crosses the x-axis. It is going to be a 0 because we take the y and make it 0. it is going to be a solution, because when we make the y 0, we can solve it for x, and for some crazy reason suddenly we decided to call it a root. So now that we understand all this, we're going to take a look at what it takes to solve that quadratic equation. When you do solve a quadratic equation, there are 4 methods for being able to solve it. And in this video, we're just going to take a look at the first of the 4 methods, which is the method of factoring. And in succeeding videos, I'm going to describe the other 3 methods. This method of factoring is based on the zero product principle. The zero product principle says this: if I've got 2 things, or 2 numbers, or 2 factors being multiplied together to be a 0, because that's what factors are. I've described that before. Factors are things that are multiplied together. So if I've got 2 things that are multiplied together to create a 0, then in order for it to be a 0, what has got to be true about one of these 2 things right here? Well, obviously, yeah, you're right. One of these 2 things has got to be the 0. So that means that either that A is 0 or that B is 0. And that's the only way to multiply 2 things together to create a 0. So if that's the case, then whenever I have a quadratic equation, what I'm going to do to solve that quadratic equation is I'm going to factor it, and then I'm going to set each one of these factors equal to 0 to be able to determine what the x is. So take a look at this quadratic equation, which frankly, most of the time your quadratic equation will look like this. I kind of set it up wrong there. And when it says to solve it, then what that means is I'm going to take that y out, I'm going to put a 0 in its place. So when I take that y out and put a 0 in its place, it now looks like this. And now I'm going to solve it by factoring. You know how to factor because we've looked at that for quite some time now. And you know that when you factor, you always first look to see if there's something common that you can divide out before you do anything else. And as you take a look at both of these terms, you see that they both have a common x. So I'm going to divide that common x out, and I'm going to write down in a parentheses what's left when I divide that common x out. When I divide an x out of here, I'm left with an x. When I divide an x out of here, I'm left with a -7. So now I have 2 things that are being multiplied together to create a 0. Now you also know that you should always take a look at what's inside the parentheses to see if you can factor it out any further, but there's nothing more that I can do with an x minus 7. So yes, here are those 2 things that are being multiplied together to create a 0. So my zero product principle said, okay, if those 2 things are multiplied to create a 0, one of these 2 things has got to be the 0. So if that's the case, then that means either this x right here is the 0. And if that's the case, okay, I'm done. I now know what x is. Or this right here could be the 0. So if that x minus 7 is the 0, then that means now I need to solve this for x. In order to solve that for x, you know how to do this. You know that that just means simply add a 7 to both sides. So when I add the 7 to both sides, that gives me x equals 7. So that means that I have 2 solutions to this quadratic equation. Either the x could be 0 or the x could be a 7. Now you know that in order to check that, then that means I should be able to take either one of these, pop them back here, right in here, do the order of operations and come up with a 0. So if I go to check my x equals 0, then what that means is I'm going to take that 0, I'm going to plug it right in here for this x, right in here for this x. So when I do, I get 0 squared minus 7 times 0. And you know that 0 squared is 0. You know that 7 times 0 is 0. And you know that 0 minus 0 definitely is 0. So I know, in fact, that yes, this is a correct solution. Now if I go to check this one, then what that means is I'm going to take that 7 and I'm going to put it right up in here. So when I put a 7 in here, I get 7 squared minus 7 times 7. And I better come up with a 0 when I do that. Now you know that 7 squared is 49, and you know that 7 times 7 is 49. And you know that 49 minus 49, yes, in fact, it is 0, so that tells me, yep, that one's right as well. But it's also very important to understand that, yes, these 2 are the solutions to that quadratic equation, but more important than that, what these solutions mean. If you recall what I described before, we were taking a look at if I was to graph this, which I will teach you how to graph it, but what I know without a doubt is that parabola is going to cross right here at 0, And it's going to cross at 1, 2, 3, 4, 5, 6, 7, and again it's 7 right here. And it's sort of kind of going to look something like this. And it is flipping up, which again I'll teach you later how to determine whether it flips up or down, but just trust me on this one flips up. And for a little bit of fun, I like to go like this, because now it makes a smiley face, and it just makes me happy. You don't have to do that, but I always do just because it's fun. But anyways, this is how you solve your quadratic by the method of factoring. Now I'm going to give you a couple more examples just to make sure we get really good at this. So let me flip this around one more time. Ooh, and try not to break it. Oh golly. Okay. All right, so a couple more examples here. Let's take a look at an equation that looks like this. 3x squared minus 13x plus 4 equal to y. And again, my directions say that I'm going to solve this quadratic. In order to solve it, what that tells me is I need to take that y out. I need to put a 0 in its place. So when I do that, this is what I get. Take that y out, put a 0 in its place. Now I'm going to solve this by factoring. Now remember, you always look first to see if there's something common you can divide out of each one of these terms, and it has to come out of every single term or you can't divide it out. There's nothing common to each of those terms. Now at this point, I'm headed for that double parentheses, and remember, you've got several options for factoring. You can do your guess and check, you can do your slide, divide, and reduce, you can do your box method, you can do your factoring by grouping, any method that you want. I tend to be a guesser checker, just largely because it's how I grew up. But this one's not too difficult with guess and check because there is only way to split up this 3x squared. So the guess and check's not going to take that long. But remember, regardless of the method that you use, check this back sign here because it'll tell you whether the signs are same or opposite. Being that it's a plus, remember that means the signs are the same. So now I need to determine whether they're both pluses or both minuses. Remember, this middle sign here will tell you what they are. This means they're both minuses. So I'm going to put a minus right here and a minus right here. Now remember, what I'm going to do is take this first term, split it up into the front slots. There's only one way to split up a 3x squared. It has to be a 3x and an x. So now what I'm going to do is split that 4 up into these back two slots. I have a couple of options. I can either use a 2 and a 2, or I can use a 4 and a 1. So I'm just going to take a guess, pop it in there, and see what happens. So let's try that 2 and that 2. Now remember, I've told you before, you check it by FOIL to make sure that you can get back to the beginning. I don't have to do the full FOIL though, because I know that 3x times x is x squared. I know that negative 2 times negative 2 is a positive 4. It's outsides and insides that I'm worried about. So when I multiply out here, I get a negative 6x, and when I multiply in here, I get a negative 2x. Those two combine to be a negative 8x, which is definitely not what I want. So you need to be systematic if you're doing guess and check. Don't just toss these before you switch things around and grab the new set. So the idea is to be able to switch them up, and I've told you guys before, don't switch both these and these because that'll just get you back to what you had before right here. However, being that these are the same, any kind of switching is not going to make a difference at all. So I know without a doubt, nope, that's not it. So I'm going to give a shot with that 4 and that 1. So I'm going to toss them in there and just see what happens. And again, check those outsides and those insides. Now on the outside here, I get a negative 3x, and on the inside, I get a negative 4x. And when I combine those, I get a negative 7x. So that tells me that, nope, I definitely do not have the right combination. So I'm going to switch things up. Again, don't switch both these and these because that'll kick you back to what you had before. So I'm going to switch this to be the 1, I'm going to switch this to be the 4, and now when I check outsides and insides, I get a negative 12x here, and I get a negative 1x right here. And that'll give me a negative 13x, and that is what I wanted. So I know that this is the correct way to factor it. Now recall that that zero product principle said if two things are multiplied together to get a 0, one of these two has got to be the 0. So if that's the case, then either this 3x minus 1 is the 0, or this x minus 4 is the 0. Now, if this x minus 4 is the 0, that's pretty easy to solve. I'm just going to add that 4 to both sides and get an x equal to a 4. Here, if that's equal to 0, then what that means is I'm going to add 1 to both sides and get a 3x equals 1. And then I'm going to divide by 3 on both sides, telling me that that x is a 1/3. And so remember, these are the two numbers that I can plug back in here and in here, follow all that order of operations, and come up with a 0 in the end. But more importantly, these are the two places where that graph is going to cross that x-axis. So if I was to graph it, then what would happen is it would cross right here at 4, and it would cross right here at about a 1/3. And again, just trust me, this one flips up. And just for fun, let's put our little smiley face in there just because it makes me laugh. But this is another example of being able to solve your quadratic by the method of factoring. So let's get one more example before we wrap this method up. And flip this thing around. Oh, finally, I'm not going to tear it up. Good news. Lock it in place. All right, so last example here. All right. So this time I've got an x squared minus 2x equal to 8. And I need to solve it by the method of factoring. Well, remember, the method of factoring is based on that zero product principle that says that if two things are multiplied together to get a 0, then one of the two things has to be a 0. But that means the two are multiplied to be a 0. That's not at all what I have right here. It's not set equal to 0. So I need to make sure that it's set equal to 0 and then move into factoring. So you guys know that that means I got to get rid of that 8. You know how to get rid of the 8. That just means I'm going to subtract it from both sides. So that would give me x squared minus 2x minus 8 equal to 0. Now I'm ready to factor it. So once again, always look to see if there's something common you can divide out before you do anything else. There's not. So that means that I'm headed to this double parentheses. And remember, this back sign is going to tell me whether the signs are same or opposites. It's a minus. That tells me the signs are different. So one is a plus, one is a minus. I might not have those in the right place, but if I don't, it'll be very easy to switch up. The nice thing here is there's only one way to split up that x squared. It's going to be an x and an x. And now I need two numbers that are going to multiply for 8. And because these are a 1 here, that means they're going to multiply for 8. They're going to subtract for a 2 because the signs are different. So that's going to be a 4 and a 2. So let's just toss it in here like this. And remember, check those outsides and insides. So out here when I multiply, I get a negative 2x. In here when I multiply, I get a positive 4x. And when I combine those, I get a positive 2x, which is close. I have the right number, I've got the wrong sign. But remember, I told you guys, when you have the right number, wrong sign, very easy to fix. Don't switch the numbers, because in the previous example that we saw, when that leading coefficient was not a 1, when we looked at this one, remember, switching the numbers is totally going to mess this up right here. So get into the habit that when you have right number, wrong sign, just switch the sign. So what I'm going to do then is I'm going to switch up these signs, and I'm going to make this the minus and this the plus, so that now on the outside I have a positive 2x, on the inside I have a negative 4x. That'll give me a negative 2x. That is exactly what I wanted. So now I can employ that zero product principle that says if these two parentheses right here, if they're multiplied together to get a 0, one of these two has got to be the 0. So either that x minus 4 is the 0, or that x plus 2 is the 0. Now if the x minus 4 is a 0, very easy to fix. That means I'm just going to add that 4 to both sides, and my x is going to be a 4. If the x plus 2 is a 0, very easy. Just subtract that 2 from both sides and get an x equal to a negative 2. And once again, these are the two numbers that I can plug right up in here, follow all this order of operations, and get a 0. Matter of fact, if I put that 4 in here, 4 squared is 16, 2 times 4 is 8, 16 minus 8 is 8, and 8 minus 8 is a 0. Yep, that works. And if I put the negative 2 in there, negative 2 squared is 4. Negative 2 times negative 2 is again 4. 4 and 4 is 8. 8 minus 8 is 0 again. So yeah, these are the two numbers that I can plug back up in here, and I will get a 0 in the end, or I'll get whatever's on the right-hand side. For that matter, I could take these two and plug them back in the beginning. In the beginning, 4 squared is 16. 4 times 2 is 8. 16 minus 8 is 8, sure enough. If I put that negative 2 up in here, negative 2 squared is 4. Negative 2 times negative 2 is 4 again. 4 and 4 is 8, and it works as well from the very beginning. But again, very important to understand that this means that if I was to graph that parabola, it would cross right here at 4 and right here at negative 2. And the most important part is now I can make my smiley face just because it makes me happy. Anyways, so this is the method of factoring to solve a quadratic. And I hope it makes sense, and if not, just let me know. You guys have a good day. Stay safe. Bye.